SPH4U, wave nature of light. 5.4 Other properties of light. So first we're going to start off with discussing the differences between polarized and unpolarized light. So unpolarized light waves vibrate in more than one plane, so light emitted by a lamp, the sun, a candle, etc. While polarized light waves vibrate only in a single plane, for example a laser. So unpolarized light waves, you can think of the light waves emitting from the source as radiating outwards like this. So they're acting in more than one plane. So say these planes, this is the light source. So there you go. You have light rays coming out from all those different planes. So that's unpolarized. Well, if you have a polarized light wave, so you have a light source like a laser, it's only shooting out that light wave in one direction. It's not going off in different planes. Instead, it's just going in this one plane. So it's not like this. It's just this. Thin films are thin layers of material that can either deflect or diffract light. So parts of light rays can deflect or diffract when they hit a surface. So whether they interfere constructively or destructively depends on their phase difference when they reach the barrier of those two substances. So typically the thickness of a film increases by 1/2 lambda each time. So constructive interference occurs at 0, 1/2 lambda, lambda, 3/2 lambda. While destructive interference occurs at 1/4 lambda, 3/4 lambda, and 5/4 lambda. So one equation that can be used within film question is this. So N of the substance, that's equal to the lambda of the light, this going through the thin film, over the lambda of the substance. This will make more sense when we look at an example question. So this is an example of thin films question. So before we start, I just want to note that when there's constructive interference, colors appear. So colors, that's equal to constructive interference. While when you see black or some other type of obstruction in the color, that is destructive interference. So we have transparent oil with an index of refraction of 1.29, which is on surface with an index of refraction of 1.35. So this creates an orange light with a wavelength of 6 × 10⁻⁷ meters. The first maximum is in the first order. So first, what's the wavelength of the oil? So we recall the equation I showed you on the last slide. So N of oil is equal to lambda of light over lambda of oil. So if we do some quick algebra to figure out the lambda of the oil is equal to lambda of light over N. So if we sub this in, lambda of light is 6 × 10⁻⁷ over N, which is 1.29. This comes out to be 4.65 × 10⁻⁷ meters. So that's the wavelength within the oil. Thickness of the oil, so we know this is the first maximum in the first order, so that's constructive interference in the first order. So thickness, that is equal to lambda over 2. So that's equal to 4.65 times 10⁻⁷. This is over 2. This comes out to be 2.33 times 10⁻⁷ meters. So that is the thickness of this thin film. So that was all of the unit that is called the wave nature of light in SPH4U. Thank you.